Today I'm going to be covering the infinite product of this right here, and we're going to use algebra and calculus too. So I'm going to use two different methods, one involving algebra and one involving calculus too. So the first one is the algebraic method, and we can say that, I'm just going to rewrite the problem, the cube root of 10 times the cube root of the cube root of 10, and this keeps going, right? So we're going to say x equals that, because I think it makes it a little easier to solve. So then, what we're going to do is we're going to cube both sides to get rid of this cube root specifically. And then we have x cubed equals 10 times the cube root of 10, since this cube root is gone now, times the cube root of the cube root of 10, and it just keeps going, right? Because now we've eliminated these cube roots. So you would think that, this is still unsolvable, but let's remember that x originally equaled this, and this equals this. So we can replace that with x. So x cubed equals 10 times x. And once we have that, we can bring the 10x over to the left side by subtracting. And from here, we can just factor regularly. So we know that when we have two factors multiplying, we know that one of them has to be 0. So what we do is we solve for 0, and this would be x squared minus 10 equals 0. Whenever you see an x squared minus something, you know that it is the result of a difference of two squares, which means that when we multiply a plus b times a minus b, or usually a equals x, we have a squared minus b squared. So even though 10 isn't a perfect square, we can still multiply the square root of 10, since the square root of anything times the square root equals the number inside of the radical, which means that x minus root 10 equals 0, x plus root 10 equals 0, which makes x equal to plus or minus root 10, and 0. However, let's consider that we're looking for the infinite product. These numbers are all positive, right? A square root can't be, or a cube root can't be negative unless it's imaginary. So we can say that negative square root of 10 doesn't really make sense, and 0 also doesn't really make sense. So we can say the final answer is going to be the square root of 10. So that's the algebraic method. We also have the calculus method. So in order to understand this method, you're going to have to know about geometric series, which are typically covered in Calculus 2, or maybe the end of Calculus 1 or the beginning of Calculus 3. So let's redo this with calculus. So we have x equals, actually we don't even need to say x, we can just say cube root of 10 times the cube root of the cube root of 10. So when we did this in the club meeting, I noticed that there's a pattern. So this is 10 to the 1/3. This is 10 to the 1/3 to the 1/3. By the law of exponents, we know that when you have an exponent to another exponent, you multiply them. So we have 10 to the 1/3 times 10 to the 1/9, and then it would presumably go on to the 27th, and it would keep going. So I noticed that the power is 1/3 to the n, or 1/3 to the n power. What that means is that this power is continually increasing by 1/3, and we'll say that n equals 1 here, n equals 2, n equals 3, right? So we keep going. So I noticed that we can't really do an infinite series, like a sum, because it's not a sum, but it is a sum when you consider the exponents, because when you multiply the same base and you have different exponents, you actually add these exponents together. So the result is 10 to the 1/3 plus 1/9 plus 1/27. We can consider this as an infinite sum or a geometric series, considering there's one number that multiplies by itself continuously, right? So we can say that this is n equals 1 over 3 to the n power. And we know that geometric series converges if the r, or the number inside, so r to the n, we know that this converges as long as r is less than 1, or the absolute value of r is less than 1. So 1/3 is less than 1. So we know that it converges, and it converges to a1 over 1 minus r. In our case, the first term, a1, is equal to 1/3 anyways. So we have 1/3 over 1 minus 1/3, which means it's 1/3 divided by 2/3, right? So 2/3, which gives us 1/3 times 3 over 2, which gives us 1/2. So we're going to say that 10 to the sum of 1/3 n will give us, this will converge to 1/2. So then we have 10 to the 1/2, which is the square root of 10. So we actually got the same answer for both. So that is how you can find the infinite product of this problem using both algebra, or not both, but either algebra or calculus 2.